Hi there. I want to tell you about a project I've been working on. It's a control panel for these robotic motors that I developed previously. Those are called Moti. I've talked about them elsewhere. I just want to focus on the UI today. But suffice to say, those motors are used to make it easier to build robots. I've got a couple in a rig here for demonstration. This one is hooked up to my computer over USB. It's hooked up to the second or any others that you might have in your network just by cutting some wire to length. All right. Now let's look at this control panel. What we've got in the upper left-hand corner is a terminal emulator for writing commands. We've got GUI components in the upper right-hand corner, and the bottom is a timeline for coordinating the motions of many motors at once. Let's explore each in turn. Starting with the console, type help. Gives me a list of commands. Clear that. Now let's start with digital write. Digital write turns a pin on or off, pin 11. Turn it on with a 1, and we'll send that to motor 1. Watch here. Okay. Let's turn it off with a 0. Good. Now let's demonstrate that sending it to a different motor is nothing more than changing the motor ID. Turn it off. Good. Okay, next up, let's look at rotate. Rotate takes a speed, 0 to 255, a direction, and a motor ID. Oh, let's give it to 2. So this motor. -1 goes the opposite direction. And 0 stops it. All right, next up is the get command. Get accesses the parameters that are saved on the motors themselves. So I'll get the present position and just the present position, so only one parameter. And I'll get that from motor 2 since we just moved it. And what it tells me is that the reply from the motor says 0 errors have been found. The parameter you requested is 6,520, and this is the timestamp when the parameter was received, the reply was received. So 6,520. There's 4,096 counts per revolution of the motor. So this is 1 1/4 or so turns of the motor. Now watch, if I manipulate this and rotate it back here and check it out again, now it's getting closer back to its origin, which is 0. Good enough. And just to show that it's stable, if I click that again, returns the same value. So that's how the console works. You type out commands and it's executed on the motors. Let's look at now these GUI components. They're shorthand for the same commands. So if I click digital write pin 11, watch this LED. It turns on or off. Over here, the analog write is used for fading a pin on or off incrementally. So it goes to the brightest value and then slide down to go to fade it lower and lower until eventually it fades off. Over here under analog read, we have the ability to read sensors that are attached to pins. So I've got this light sensitive resistor here. I'll click this button and it tells me that the value is 918. Okay, let's cover it up, changing the light that's falling on it, and query again, and now it's a different value. And if I really occlude the light, It'll give me a very low value. The range is between 0 and 1023, which is a 10-bit number. And this is good for knowing the limits of your sensors in a particular environment. All right, now we have the dial here, which is used to control the position of the motor. Move it slowly or move it fast. Okay. Those are the GUI components. I can actually change which motor is being affected by selecting a different one from the numbers that are just underneath that section. So click on 2, the dial color changes, that's your first indication. And underneath the dial you see it says Mo2. So that's the active motor. Now when I click the LED, it turns on or off. All right, now let's look at the timeline. The timeline is used for coordinating the motion of many motors. Along the horizontal axis, you have like intervals of time. Right now it's set to 3 seconds. And the vertical axis is degrees. And it's set to, the intervals are 360 degrees. I control the state of the timeline with these 4 buttons above it. Let's click on Edit. And what it allows me to do is drag these points around the screen to set different positions. All right, and then I can lock that up, and playing it back is as simple as just going back to the first position, hitting play, and watching it go. There you go. So let me pause here. I'm going to move the videos so you can see the rest of the timeline. Now, that's great. So you can, manually or with these nodes, you can position the motors. But what I can also do is capture the position from the motors. You could imagine having a robot and you want to move its arm and then record that. So we can do that as well with the timeline. I just select the interval that I'm interested in. I'm going to put the motors into the capture from state. So look at the dial and just above it, you'll see a little button. I'll click that and it changes from rotate to capture from. I'll do that for both motors. And now what I'm going to do is move the motors with my hands. Then I'll click the last button above the timeline, which is the sync button, and it records those positions. I'll go to the next node, or the next interval, go elsewhere, keep turning. Now this time, watch when I hit sync. The timeline's actually going to grow. And it does so to accommodate the actual recorded position of the motor. Good. So let's now go back to the first interval and we'll hit play. All right. When it gets to the end, it's just going to loop around and play again. So that's it. That's what I wanted to show you. That's where things stand at the moment. I have a lot of future plans for this. I want it to be fully programmable. I want to have the ability to export these timelines so that you can implement them in a different programming environment if you need. And I'd love to hear from you guys to see what you think, where you would like to see this go, what you think it would be useful. Just so you know, it's built in JavaScript using Node.js and Express on the back end, and the front end is done in React. And I'll probably release it as a Electron app at some point. Okay, that's it for now. Thanks for listening. I'll talk to you soon.